In this video, we're going to be talking about the difference between constant speed and constant velocity, how they differ conceptually and mathematically. Both of the two are not terribly hard. There are some subtle differences that will make a big difference in calculating and figuring things out for both the two different formulas. Okay, so let's start with constant speed. S equals d over t, which is speed equals distance over time. All of these values are scalars. Scalars mean that all of your values are positive because they're only measuring the magnitude of the number. The magnitude of the number is just simply how large it is without considering direction. If you take a look at our diagram on the left, a person walks from 0 to 15 meters and then back from 15 meters to 5 meters in a total of 5 seconds. So we're going to go ahead and take our S equals d over t formula and calculate that out. All right, so we completed our speed calculation. So in my numerator, I have 15 meters plus 10 meters. The reason I have that is because our person has traveled from 0 to 15 meters, which obviously is a total of 15 meters. And then if you travel 15 meters back to 5 meters, then you go 5 meters back and 5 meters back again, which is a total of 10 meters backwards. So the total distance or the total length that they've covered is 15 meters plus 10 meters, which is a total of 25 meters. According to our information up here, the total time equals 5 seconds. So if we were to solve for the constant speed or average speed, we would take 25 meters, divide that by 5 seconds, and that comes out to 5 meters per second. And then in addition, on the side here, I made a little note of what a scalar is. It's just measuring the magnitude of the number. So all of our numbers are always going to be positive for speed equals distance over time. All right, that takes us to our next formula, V equals delta x over t. Delta x means displacement, which is final position minus initial position. So xf minus xi, x naught, x with the little subscript 0, it would be a similar version of xi. Okay, so for delta x, that's your displacement. That's how far you are from where you started. Okay, so I'll make a little note that this is displacement. Okay, now the big difference with velocity equals delta x over t is 2 out of these 3 values are vectors. Velocity and displacement are vectors, which means they both consider direction, which means they both can be positive or negative. Time is the only exception in that formula that is not a vector. That one is also a scalar value, just like all of our values from our speed equals distance over time formula. So when calculating V equals delta x over t, we want to make sure we're conscious of our directions and realize that we can have positive and negative numbers with velocity, and that's okay, because velocity is basically the same thing with speed, except it considers direction. Therefore, it could be positive or negative. Okay, so let's go ahead and calculate velocity equals displacement over time. All right, there you go. We've got our constant velocity of 1 meters per second, which is basically our average velocity for the total of the 5 seconds. So all you have to do here is find your displacement by finding your final position. Here's our final position. This is where we ended our problem. And then we subtract our initial position from our ending position. So we simply take a look at where we're ending, which was 5 meters, subtract where we're starting, 0 meters, and then divide that by our total time of 5 seconds. Okay, now you might be wondering why velocity comes out to 1 and speed comes out to 5 when they're doing the exact same thing. The reason being is because velocity considers direction. For a large majority of the time, it has a positive velocity, and then for a part of it, it also has a negative velocity. So if you average those positive and negative velocities together, that leaves you with 1 meter per second. Another way to look at it would be that if you were to travel 1 meter per second, which is traveling forward 1 meter every second for a total of 5 seconds, where would that leave you? Okay, so if you traveled 1 meter every second for 5 seconds, that would take you forward 5 meters. Okay, now if you take a look at everything over here, when everything's said and done, the person has traveled from 0 to 5 meters. Okay, without considering all the parts in between, that's why it's saying on average, it's like they traveled 1 meter per second to get to that final destination, where speed has a better gauge of how fast the person is actually moving throughout the entire 5-second interval. On the side here, again, I made a little note of what a vector is. Vector is something that has a magnitude and a direction. So it's a value that is going to be positive or possibly negative as well. Okay, so we've completed our 2 different calculations. You see that they look fairly similar. They have to do with how fast an object or a person is going, but your answers can be very different depending on what's happening in the problem. Thank you for watching and listening.